because my thought is, and I'm not going to have you guys do this because not everybody's in the same boat, is if you have kept up with all the homework assignments, I guarantee you look through any of your practice exams, it's almost done. All right, that's why we do those first 7 days, because those are the topics most commonly asked. So if you've been staying on top of the homework assignments every day, you look through one of your exams, it's pretty much done probably. I'd say maybe less than 10 questions have been answered. That's why we went over those topics the first 7 days, because they're the most commonly asked. And here are some that are not commonly asked, but we should be aware of. All right, first one I'm picking is number 5. They always put some type of circle fact on there. It's not consistent though, and that's the problem. Okay, it's never consistent, the circle fact that they use, and there's a ton. In fact, I think your cold hard fact sheet does an awesome job. I think there's like a full page in your cold hard fact sheet that is just strictly dedicated to all the circle facts we went over. All right, so make sure you reference that. So here we go. We got to find arc BC. First thing we need to review, that angle of 28 is called an inscribed angle. So I got to remember the fact. Inscribed angle. How do I find it? Connor?
1/2 the arc length.
1/2 its arc measure. Okay, inscribed angle is always equal to 1/2 of whatever the arc was. So in this case, I'm going to double 58 because I already know this inscribed angle. So I'm going to take half of whatever its arc was. So to get the arc, I might as well double it and get 56 degrees. And you'll notice that's a choice, right? Pick me, pick me. I actually did something important, so pick me. No, we're looking for arc BC. So how do I get from that 56 to arc BC? Well, you got to read carefully here. What did we tell you AOB was? That's a diameter. There's the key to the whole thing. All right, so these two arcs should add up to, AC and BC should add up to buck 80. Yep. So we got 180 minus 56. And that's what, 124? There we go. What, Theo? Okay, thank you. Easy problem when we do it together, but if you don't know the inscribed angle fact, good luck. All right, good luck. So again, I wish they were more consistent on the circle facts, but they are not, unfortunately. All right, next up, 17. This is just a vocab thing. All right, this is more of a vocab thing. Isosceles triangles, they use this term base angles. One of the base angles, is that the congruent ones or the non-congruent one when they say base angles? The congruent ones. Those are the ones across from wherever your congruent sides are. So in this case, if they tell you one is 42, the other one is 42. And they're looking for the measure of the exterior of the vertex. That's the non-congruent angle in an isosceles triangle. Exterior angle though, so I need to take one of the sides that make up the vertex angle and extend it. This is the angle I'm looking for right now, right there. Okay, not looking for the vertex angle, the exterior angle. Couple ways we could do it. I know you could take 180 minus 42 and get that angle and subtract it from 180, or the other way, and again, no stone unturned. I don't know if this will ever be asked. Exterior angle is always equal to, anybody remember what these were called?
Interior.
The sum of the remote interiors. All right, so if you want this angle, I can just do 42 plus 42. Any exterior angle of a triangle is equal to the sum of the two non-adjacent, we call them remote interior angles. Okay, yes, I know I could get there by doing 180 minus 42 and then subtracting that again from 180, but I don't know if it'll ever come up that you need that theorem. Exterior equals the sum of the two remote interiors. All right. So just going over some facts. that we have not gone over in a while. Anything else there? Okay, next one. 22. All right, ABC. I got some midpoints now. M is the midpoint of AB. N is the midpoint of AC, not BC. Let's stop right here before I label it. MN, we got a name for it. Mid segment. Anytime you connect the midpoints of two sides of a triangle and connect them, you have what's called a mid segment. There are two properties of a mid segment we should be aware of. All right, two properties of a mid segment. MN, it deals with the third side, the side it does not connect. So MN and BC have a couple of relationships we need to be aware of. Well, they're parallel to each other. Yep. If it's a mid segment, they are parallel. And has to do about their lengths. Gage?
M is equal to half of B.
MN is equal to half of BC. Yes. A mid segment is always equal to half its third side. So they're parallel and half the third side. Now we can do the problem. X plus 13, 5x minus 1. All right, we are certainly not going to set them equal to each other. I will. I know that's incorrect. But can you adjust it for me now that you know these two facts? I'm sure that answer's there, by the way, when you solve that, because they want you to set it equal. How do you adjust it to make them equal, Zach?
Multiply BC by 1/2.
Multiply BC by 1/2, or I can multiply MN by 2. Either one. Yep, either one. And I didn't do this yesterday. We didn't. Mrs. Linehan and I did not do this on purpose yesterday. We put very little traps on that quiz because we wanted to make sure we tested you on the content, not falling into a trap. All right, bud, here you go. Here's a trap. X equals 9, right? Oh, pick me. Choice 2. But what are we looking for? MN. Okay, we're looking for MN here. All good? Everyone good? Mid-segment? So we're all, you can see all we're doing is going over like small little facts that may or may not pop up. I have no idea if mid-segment will be on there. I'm not confident. Oh yeah, and then we're doing 35. 6-pointer, big dog. Haven't talked any statements, reasons, proofs yet. All we've done is coordinate. I have no idea if it's going to be coordinate or statements, reasons on part 4. No idea. Until about a minute before you walk in. Oh, it's been a while. Yes, there is partial credit, but not if you just write the givens. Speaking of the givens, and this is not a story, a fake story like I told SOHCAHTOA, and you guys all believe me, it was Pocahontas' brother. All right, this is a true story. I don't know how many years ago, but because when we grade a proof, we have like, all right, this is worth 6 points. This is a 5-point proof. This is a 4-point. Give 4 points. Give 3 points, etc. It said we needed to take off 1 point if some of you lazies just did that. Okay? Right out the darn givens.
You're going to take out.
They did. Yeah. All right? If you need an ice pack because your wrist hurt from writing all that, let me know. I'll make sure you get one. All right? Yeah, you know me. I'll be that type. All right, if you need an ice pack from writing all those givens in, let me know. It's so tough. Such a rough life. First world Delmar problems. All right, I got quad, A, B, C, D. A, B, congruent to C, D. A, B, parallel to C, D. Ooh, we got a lot going on. I don't care what you do now, but I'm just warning you. They're probably going to take off a point if you don't write it all in. This is so much. All right, I don't care. Suck it up. As you're writing them all in, a reminder, you can use colored pencils, highlighters if you want to bring them. That is fine, especially for a statement's reasons proof and you want to highlight stuff. Go ahead, but just don't do your proof in colored pencils, please. Please do it in blue or black pen. Any abbreviations I have used over the course of the year is fair game. If you start using your own abbreviations, you're playing with fire. All right, we're ready here. I got to prove G is the midpoint of EF. Well, that ain't happening unless I know which two segments are congruent. EG and GF. So that's going to be my goal with you right now. Forget about the mid. That'll come afterwards. All right. G is not going to be a midpoint unless EG and GF are going to be congruent. So that's our goal right now. Get those congruent. And it's been the same story all year long. Those segments aren't going to be congruent unless the triangles they contain, EG and GF, are congruent. And I believe there's only one pair of triangles up there that contain them. Everyone see them? So that's going to be our goal right now. Get me EGA congruent to GFC. And actually, this is a June exam, right? So my students 2 years ago took this same exam and did this same exact proof. And you know what they did? They didn't read. Not a parallelogram. It's only a quadrilateral. You can basically apply no properties here. Okay, so don't start telling me, quad implies opposite sides congruent. No, this is a quadrilateral. That is it. Not a parallelogram yet. So you can't use any properties right now. Everybody good? No properties yet. What's up, Zach?
Wait, can you make it?
Oh, we can. Well, we probably will. Don't steal my fire. Let me teach. I'm the one with the pen. But right now in step 2, everyone's good. No properties. Don't start using properties of a parallelogram because it's not. And I know that was a common mistake when kids took this. I got to mark my diagram. I'm just getting fired up. A, B, C, D. Those bad boys are parallel. And I also have DE congruent to BF. All right, I'm good. Zach said, hey, can I show it's a parallelogram now? What do you think? Do I have enough info? Yeah, special case. Don't write special case. Remember, you'll be a special case before you leave Jim D. All right, you want to write that down. All right, so we could say ABCD is a parallelogram. You better tell me that before you want to use any of its properties. Why is it a parallelogram? Because I have one pair of what? Opposite sides, congruent and parallel. That implies a parallelogram. All good. All right, now we can use some properties. Okay, now we can use some properties because remember the two triangles we want congruent? I have nothing right now. I have nothing written down that says these angles or these sides are equal. All right, we got I can pretty much rule out this one because HL, because I don't think I'm getting a right angle anywhere. And I need right triangles for HL. All right, anybody see any angles here? Here we go. Sophie, first pair.
BAC is congruent to DC.
to DCA.
How's that gonna help?
Which angles again?
DC or DC, whatever you call it.
This one?
Yeah, is congruent to BAG. It's alternate interior.
Okay, where are you going from there? Because
Well, 'cause then
those aren't inside.
you know that the angle A and angle C, they're congruent because they're opposite. So then you can do subtraction.
Okay.
Substitution.
Okay, I'm going to get there a little quicker, but yes, you could do that. Okay, no, you're right. I am going to eventually you're going to get these two congruent, right?
Yeah.
You could do subtraction, substitution. That's fine. Do it. That's fine. All right, I'm just going to get there because of time's sake. I'm going to get there a little quicker. Okay, here's how I'm going to get those two angles. All right, everyone see the one Sophie's saying? She's saying, hey, do subtraction, substitution. Yeah, that's fine. We could also say instead, now that this bad boy's a parallelogram, AD and BC are parallel and they're congruent to each other. That'll be a separate step. All right. Parallel lines imply, parallelogram implies opposite sides parallel. And now, Sophie, I'll get there right now by saying, okay, now those are also alternate interior with AD and BC. Okay. So angle EAG is congruent to angle ACF. If I'm doing something or you want me to re-explain it, let me know. Parallel lines imply alternate interior angles congruent. And that gives me my first pair of angles. Done. All right, so I have a pair of angles. Anybody else want to chime in? Jacob.
Angle AGE and FGC.
Right? Why not? I got to throw the verts in there. I got to give the verts some love. AGE and FGC. AGE. AGE, FGC. Vertical angles congruent. Oh, it's been so long. Come on. Another pair of angles down. I hate to break it to people, but somebody's going to have to give me a pair of sides, right? Because angle. Oh my God. Please don't do that to me and embarrass me like that, please. All right, we're not proving these bad boys similar. Kira, what are you going to chime in with?
AZ is congruent to BC.
Yep.
Because in a parallelogram, opposite sides congruent.
Mhm.
And then you already have BF is equal to ED. And then so you do AD minus ED. And then BC minus BF. And then you substitute.
There we go. One thing you're not going to do, tell me the property diagonals bisect each other. Why? EF's not a diagonal, so that ain't happening. Okay, that was another common mistake. Oh, diagonals bisect each other, so these are, AG and GC, EG, and nope. That's not they're both not diagonals, so that property does not apply. I am forced to do what Kira just said, which is first show AD and BC congruent. This is going to be a long proof. Darn right it is. It's a 6-pointer. It's the big dog. Parallelogram implies opposite sides congruent. And then we do subtraction. Jeez, I haven't done this in ages. AD minus ED. And what else? BC minus BF. Subtraction. And I promised you, and I stayed to my word, starting from Unit 2, and now we're almost done with the year. I'm so sad. Substitution. Also, have I discussed our interactions after the last day of class? After the last day of class, I am not going to acknowledge, recognize any of you if I see you in the hallway or in public. Okay? Our student-teacher relationship is over. Done. As soon as you walk out that door on the last day of school. All right? If you try to acknowledge me outside of this building or in the halls, I will just look at you and be like, I have no idea who this person is. Okay? And probably try to embarrass you. All right? I will have no recollection of who you are.
Do you know who the person is, or do you just forget?
No, they'll be like, hey, Mr. Carlin. I'll be like, no idea. And just keep walking. So just a heads up on that. All right, I'll warn you right now. What do I got? AE congruent to FC by substitution. Let me mark that on the diagram. AE. All right, let's talk method. This is angle, side, because the side is clearly not in between. So tell me the triangles are congruent. Triangle AGE. And this is another thing. I know you're not going to like it, but yes, they will. Whoever is grading it will be told if you do not write the triangles in the correct order, that is a point off. All right, that is a point off, that if you don't match up the sides and angles correctly. Age, so if I go AGE, what do we got to go? CGF? Angle, side. And we did all that to show EG and GF congruent. Has it been long enough? Can it still roll off your tongue? CPCTC. But that wasn't our proof statement, was it? Whew, 11 steps, jeez. G is the midpoint of EF. Definition of a midpoint. Maybe the only hint of an acknowledgement I may give you after the last day is A, I kind of liked you. B, nobody else is around. So there's no proof, no video, no nothing that I acknowledge you. So those two things have to happen for you to maybe get an acknowledgement from me after the last day of class. Abby, go ahead.
Is it okay in step 3 to say they're parallel and congruent, just all in one, so you don't have to?
Yep, just make sure in your reasons you put parallelogram implies opposite sides parallel and congruent.
Yeah.
That's fine. Yep, just make sure you mention that. Before I give you what I need you to work on your own or in your groups, I believe this could have been done without mentioning a parallelogram. Okay, I believe so. Let me just check here. I don't think you had to mention it was a parallelogram because you already had the vertical angles, right? And then you would have had, let me just, before I open my mouth. Yeah. Okay, what would have happened was you could have proved these two big dogs congruent here. See those two triangles there? You already have a pair of sides. It has a reflexive side AGC. And then you could have said the alternate interiors are congruent, which I believe Sophie gave me at the beginning. And does everyone see you have side angle side right there? Yes, side angle side. Right? Then because of those two triangles being congruent, CPCTC says these angles that we got congruent because of alternate interior are congruent by CPCTC. And then you do your subtraction on AD and BC because they're equal by CPCTC. All right, I know I just went over that pretty quick, but you could have done it without showing a parallelogram. I just want to throw that out there. Last thing I'll tell you is, remember, I'm not grading this, so please be neat. Okay, I'm not grading this. All right, if it looks like you did this with your pen in your mouth, that might be a problem for whoever's grading it. And I don't know how seriously they will take it. All right, here's what you guys have. Couple things. Go ahead and finish. All right, that's what I'm asking for tonight. If you decide to try it out or not, finish this exam, and then remember tomorrow. I warned you 2 days. I warned you 2 days ago. You need the January 25 either printed out or downloaded into Cami. Yes.
Can I print it out quick?
On your own. I want you to finish June 2023 right now. That's what we're working on.
Come on.
Here we go. Whatever we didn't finish or whatever you didn't finish in that exam, go ahead. Call me. You guys know where the answer key is in the master library.